This video covers everything we talked about today, Lesson 15, Unit 1 in 8th grade honors math. The first question says, each histogram shows the bowling scores for the last 25 games played by each person. Choose two of these people to join your bowling team and explain your reasoning. Please pause this video and try 15.1 bowling partners. So there's no right or wrong answer to this question, but I'm going to summarize a few of the things we talked about in class. Notice that person A has a collection of very low scores between about 80 and 140. But they also have some high scores from 160 to 200. So you might be inclined to choose person A over, say, person B, who doesn't have any scores above 160. Now, on the other hand, you might decide that consistency is more important to you, and that you want to choose person B over person A because even though their scores aren't as high, they also aren't as low. Person B is never scoring in this range from 80 to 200. Now, let's take a look at person C. Person C has some very high scores. We can see that they get all the way up to even 200. But they also have some very low scores. So if you chose person C, you would really be taking a gamble, because while you could end up with some really high scores, you could also end up with some really low scores. The same thing is true of person D, where you see that they sometimes bowl a nearly perfect score, but other times their scores are more average to low. So the point of this activity is for us to look at how the center and the spread of our data influence the choices that we make. For example, we can see that the spread of person D is much larger than the spread of, say, person B, who's very consistent. But maybe we want to take a chance on them because we know that they can score in the 290 to 300 range. We could say the same thing about comparing person C to person B, in that person C is less consistent, but they can score higher. The purpose of this activity is to show how data about center and spread can influence those choices. You might also just decide, I want to go with people who have the highest center or the highest average. And you would decide, well, I can see that the average of person A is somewhere around 130, of person B is somewhere around 130, person C is maybe also somewhere around 30 to 140, and for person D, especially if you remove the outlier, which we talked about yesterday, you would end up with a much lower average, and that could influence your choice. The next activity, 15.2, is another comparison of data sets. It says all of the marathon runners from each of two different age groups have their finishing times represented in the dot plot. Which age group tends to take longer to run the marathon, and which age group has more variable finishing times? Explain your reasoning for both. Pause this video, answer these two questions, and then come back. So there's a few key points to notice here. We see that the 40 to 49 age group tends to take longer. The center of their data is somewhere in the mid-300s range, whereas if we look at the 30 to 39 group, the center is more towards the low 300s. We just know this by looking at the graph and seeing where the approximate or just about middle of the graph lies. Now, when it says which age group has more variable finishing times, it's asking us about the spread of the data. So we can see that age 30 to 39 goes from about 230 to 380, whereas age 40 to 49 goes from about 350 all the way to 450. So we can see that 40 to 49 has much more spread out data than the 30 to 39 group. This should help you to see the difference in marathon times across these two age groups. Our final activity is called comparing measures. It says, for each group of data sets, determine the best measure of center and measure of variability to use based on the shape of the distribution. Determine which set has the greatest measure of center, and determine which set has the greatest measure of variability. In terms of variability, you don't need to decide on a specific measure of variability because we've really only talked about calculating the IQR. We didn't talk about the others. But when it comes to thinking about the measure of center, what you're considering here is whether it would be better to use the mean or the median to understand the data in these graphs. So for example, let's take a look at 1A to start. In graph 1A, we can see that we have a symmetrical distribution, meaning that if we folded the distribution in half, it would end up exactly the same on both sides. Another way to think about this is that the mean and the median are going to be about the same. Because if you took the average of these points, you would end up at just about -8. Now, let's compare that with a graph like, for example, 3A. If you look at graph 3A, we see that we have some points, a gap in our data set, and some more points. Even though we'll be able to find the mean and the median, they'll be different. The reason is because there's this gap in the data. So while the average or the mean might end up somewhere around 7 or 8, because there are so many more points in the 10 to 11 range, the middle point is going to end up being different if we cross off our points. The median ends up right here at 8. Again, the mean is going to be skewed. I circled 7 to 8, and I really should have circled something closer to, say, 6 to 7 for the mean. And the reason it's going to be skewed is because we have all these points over 1 that are going to affect our mean. When we have data points that are really far away from each other with gaps in between, it's often better to use the median instead of the mean. So all I would be asking you to write is median. In other words, it's better to use the median when distributions are skewed, meaning when they're not regular, when there's more data points on one side and a few far away on the other side, or when data sets have major outliers. That also means it's better to use the median because those outliers are going to have a really big effect on our mean, like we saw in yesterday's lesson. So your job is to take a look at these data sets and to tell me which data sets we should use the mean, for which data sets we should use the median, and for which data sets the mean and the median are just about the same. Then you need to find the data set that has the greatest measure of center, and you need to find the set that has the greatest measure of variability, meaning that the points are most spread apart. This is your last activity for today in ClassKick. When you finish with this activity, your next step to be caught up on classwork is to complete today's exit ticket. After the exit ticket, please be sure to take a look at the study guide from yesterday. Again, it's in the Thursday folder because that's your homework that's due on Monday that will help you study for Tuesday's test. If you want to look at a list of everything you need to do if you missed class, just look below this video in the asynchronous work folder, and I've listed everything out for you. The last thing to note is that on the final page of ClassKick, there's a summary of what we just talked about. When distributions are skewed or when outliers are present, The median is usually a better measure of center. This last page is always a great resource to help you review notes and the main ideas from the lesson.